Hello everyone. In this video, I will discuss about difference between internal combustion engine cars and electrical vehicle cars along with type of mounting system used in electrical vehicles for supporting motor weight. I will start with comparison between IC engine with electrical motor. Total evaluation factors are 29 and I will quickly go through them. So let me start with the RPM. RPM of petrol vehicle goes from 800 to 6000 compared to electric vehicle which is from 0 to 18,000. RPM range and variation is big in electric cars. So the clear winner in this aspect is electrical cars. If we talk about transmission, for petrol cars, complex transmission is must to get long range of speed from 0 to 160 kilometers per hour. Range from 800 to 6000 RPM generated by engine. Higher weight complex mechanism. For electric cars, very simple single speed transmission is needed for speed reduction as motor RPM varies from 0 to 18,000. Reduced weight and simple mechanism. Speed of electric car is directly proportional to frequency of AC power supply and therefore speed can be increased or decreased by increasing or decreasing the frequency, which is done by inverter, also called the brain of electric car. Reverse gear is not needed as this can be achieved by reversing the polarity of current. Type of mounting system for both types, 3-point, 4-point pendulum system with single and twin torque rod is used. We'll discuss about the mounting system later on in this video. Idle. Idle for petrol and diesel car is a problem and requires mount stiffness to be tuned for powertrain modes. With three-cylinder, first order is concerned and balancer shaft is needed for roll and yaw balancing. For four-cylinder engine as well, balancer shaft is required in some cases. Also with reduction of RPM to as low as 700, for some of the three-cylinder car, placing powertrain modes between very short frequency range is a challenge. It is challenge as idle needs mount to be soft for good isolation. For key-on, also higher isolation is needed at the same time. Movement of powertrain should be restricted, and for that we need stiff mounts. For key-off, high damping is required. For electric cars, no issue as no firing of cylinder is taking place inside the motor. An inverter converts the DC supply from lithium-ion battery power bank to three-phase AC supply for wheels. Idle is quiet and key-on, key-off is not a concern. So if I just summarize this page, for RPM, the clear winner is electric car. In terms of transmission, again electric car because the transmission system is very simple. Single speed transmissions, their type of mounting system, both are same and same type of mounting system can be used, but for electric cars the mounts are more simple and not very complex. Idle, clear for idle and key on key off, clear winner is electric car. In terms of torque for petrol and diesel cars or IC engine cars, it's very difficult to produce high torque at low RPM. Electric vehicles can easily produce high torque at low RPM. If I see the next factor, that is fluctuating torque, for IC cars, torque fluctuation is not that wide and durability of mount is not a big concern for mounts in X direction, that is driving direction, in a pendulum system. For electrical vehicles, instant torque variation over a big RPM range results in high loads in driving X direction, which results in concern for mount durability in pendulum system. For 3-point or 4-point system with all mounts located above COG, this variable torque load can be split into two components in X and Z direction. So with 3-point system, 4-point system, we can design mounts more simple. Inertia forces for petrol and diesel vehicles are high because of large weight of engine and complex transmission. Durability is a concern for mounts in vertical Z direction from road excitation. For electrical vehicles, inertia forces are low because of low weight of motor and single speed transmission. No durability concern in vertical Z direction for mounts from road excitation as force values are on lower side. Next evaluation factor is dual isolation for high frequency. RPM varies from 0 to 6,000, and second and fourth order excitation can be calculated between range of 200 to 400 Hz for petrol or diesel cars. Operating frequencies are not as high compared to electric cars. Maybe gear whine can be a problem. At higher frequency, thus dual isolation is not needed or is not a big concern. For EVs, RPM varies from 0 to 18,000 and order value is as high as 30. That means frequency range goes from 0 to 9,000 Hertz. Frequencies are in kilohertz, which is very high and results in acoustics issue for human ear as the frequency range is in audible range and for sure require dual isolation. So if I just quickly summarize this slide, for torque, clear winner is electrical vehicles. For fluctuating torque, durability, petrol and diesel vehicles, they don't have that big concern compared to electrical vehicles. Inertia forces for petrol diesel car are high, so clear winner is electrical cars. Dual isolation, clear winner is petrol diesel car because the frequencies are not very high and we don't need it, but in case of electrical vehicles it's must. In terms of power source, for petrol and diesel vehicles, it's the fuel is petrol or diesel, and for electrical cars it is lithium ion battery. In terms of charging time and fuel recharge, petrol diesel cars just take 3 to 5 minutes for full tank, and electric cars they take minimum 60 minutes with a supercharger, but generally this time is always on the higher side. Fuel storage, they don't petrol or diesel cars don't require any cooling mechanism, but this is must for electrical and vehicle cars because battery produces lots of heat. Energy density of fuel for petrol and diesel car is 1200 watt hour per kg. Compared to electric cars, it is just 250 watt per hour per kg. Noise level at high frequencies. Noise level is low for IC cars compared to EVs. It is high for EVs because frequency goes in kilohertz. Vibration level. In internal combustion engine, reciprocating motion is converted to rotational motion, and this results in problem like mechanical balancing, which results in higher vibration, and for that counterweights are needed for dynamic balancing, and that results in heavy setup with increased cost. For electrical vehicles, the way inverter converts the frequency of AC supply to control speed, in same way inverter also controls amplitude of AC signal, which is proportional to power output of motor. That means higher the amplitude of AC signal, higher will be power delivered by DC motor to drive wheel. With electric vehicle, power output is uniform and direct rotation motion is obtained from induction motor. Thus, there are no mechanical or unbalanced forces. In terms of pollution level, we all are aware that pollution caused by IC engine compared to EVs, which is EVs are more environmental friendly and don't emit any CO2 or other toxic gases. So if I just summarize this slide quickly, for power source, lithium ion battery is a better choice. In terms of charging time, petrol diesel cars are quick. Charging is a concern for electrical vehicles. Fuel storage, cooling mechanism is not required in petrol or diesel cars, so they are the winner. Energy density of fuel, again petrol and diesel cars are the winner. They have a high energy density of fuel. Noise level, again from acoustics point of view, petrol and diesel cars are better. Vibration level, then electric cars are clear winner. Pollution level, again the electric cars are the winner. So next slide, the first is approximate weight of power unit for IC engines. The powertrain weight is varies from 130 kgs to 250 kgs approx, and for motor it is approx 32 to 80 kgs. So here the lightweight is preferred, and so electrical vehicles are the clear winner. In terms of power, petrol or diesel vehicle can produce 140 kilowatt and electric cars can produce 270 kilowatt. Weight to power ratio for petrol and diesel cars, it is 0.8 kilowatt per kg, and for electric cars it is 8.5 kilowatt per kg. COG of the car for petrol and diesel cars is generally higher compared to electric cars. For electric cars, battery pack is distributed below driver or co-driver and rear passenger seats. This is good for stability of car and for comfort as well as we are closer to the ground. Regenerative braking for energy savings. For IC cars, separate BLDC motor and battery pack is needed. For EVs, very effective and easy with same motor work as generator as rotor speed becomes more than a stator speed. Safety. IC cars are not safe because of high inertia forces because of high powertrain weight. EVs are safe because of low inertia forces and also because of battery pack placed on seat floor that will make car more rigid and strong inside collision. Maintenance and driving cost. It is high for internal IC cars compared to EV cars because for IC cars we have to buy the fuel and the cost is pretty high compared to the electricity. Heat. So if we look at all the factors on this slide, for all the factors which we discussed, the electric car is clear winner in terms of weight of power unit or a power or weight to power ratio or a COG of the car or regenerative braking or in terms of safety or maintenance and driving cost. So electric car is a clear winner. Heat generation by power source. IC engine generates lots of heat and require proper cooling mechanism compared to EV motor in which no heat is generated. Cornering. In IC cars, low weight of fuel results in easy cornering compared to electric vehicles in which high weight of lithium battery at flow results in difficult in cornering of a car. Electric vehicles cost 0.01 USD per mile, almost one-third cheaper compared to IC cars. Maintenance cost. IC cars require high maintenance cost compared to EV. Initial buying cost. Buying cost for IC cars is low and electric cars are more expensive. Again, this depends on lot on volumes and reducing the cost of power pack, that is batteries. Exhaust pipe for burnt fuel or gases. In IC car it is needed and design is complex. For electrical vehicle, it is not required as there are no exhaust gases. So it is environment and nation friendly. IC cars create pollution, but EVs are both nation and environmental friendly. So if we just look on this slide, based on all evaluation factors, for heat generation, electric car is a winner. For cornering, petrol and diesel car is a winner. For cost per mile, again, electric car. Maintenance cost, electric car. Initial buying cost, petrol and diesel car is a winner. Exhaust pipe is not needed in electric cars, so it is a winner. Environment and nation friendly, no pollution, so electric car is a winner. So if we just look stats now, based on 29 evaluation factors, electric vehicles are clear winner with 21 smileys, green smiley faces and 8 red angry faces. For internal combustion cars, 9 are green smiley faces and 20 are red angry faces. So the clear winner or the every nation should now target electric vehicles, and they should have some specific targets to, like by end of 2030 they should finish all internal combustion engine cars. Now on this slide I will talk about types of mounting systems. So is the mounting system which I'm going to discuss here, they will be common and I would be specifying. So pendulum system is a very common choice for 3-cylinder, 4-cylinder types of engine. But if electrical vehicle platform is a carryover platform, any 3-cylinder, 4-cylinder engine, then they also prefer using pendulum system because it's very easy to implement and they have the same positions. 3-point system, pendulum system is the system in which we have 2 mounts above COG and we have the third mount which is below COG, which is also called torque rod. We can have 1 torque rod in a pendulum system and we can also have 2 torque rods in a pendulum system, and it all depends on how much torque being generated. Higher torque means we need to have 2 torque rods. 3-point system is a system in which we have all the 3 mounts which are load carrying and also they take up the torque. in X and Z direction. 4-point system, again, we have 4 mounts and they are load carrying as well as torque reacting in X and Z direction. So in pendulum system, the task is little bit separated. So all the 3 mounts in Z direction, they carry the weight. So RHS and LHS mount, they carry the weight of the mount in Z direction. And since the third mount is below COG, so there is no weight on the third mount, so it has no preload. In terms of taking the torque fluctuation, then all the 3 mounts take the fluctuation of torque in X direction, that is driving direction or reverse direction. So task is separated. So Z direction is taking all the loads and X direction is taking the fluctuating torque. But in any 3-point system or 4-point system, which is not a pendulum system, both the task taking the torque and taking the load is not separated very well. So on the left corner, you can see pendulum system with 2 tight bars. Means if the torque is high, we need to have 2 torque rods. This on this screen, you can also see the mounts, cylindrical mount, wedge shape mount, and the torque rod. The common choice. Types of mounting system in electrical vehicles. So if we just see the pendulum system, so VW Golf, VW EU up, Renault T20 EZ, Renault Kangaroo Mini E Smart, Chevrolet Volt, BMW i3 and VW MEV. They all are pendulum system because generally the pendulum system is not the first choice, but since these platforms are carried over from 3-cylinder, 4-cylinder, 6-cylinder, so they preferred using pendulum system. So if we talk about 3-point system, then Tesla, which is not a carryover, so it is 3-point system. Nissan Leaf is a 3-point system, and Fiat is again a 3-point system. 3-point system means the mounts are located above COG and they are taking the load, and the load is distributed, the preload or the weight is being taken care in Z direction by all the 3 mounts. 4-point system, BMW i8 has a 4-point system. So main requirements for EV is to withstand high fluctuating torque. Instant torque variation over a big RPM range results in high loads in driving X direction during acceleration. So generally in electric vehicles, the car accelerates and the RPM shoots quickly and then it comes back to 0. And there's a torque fluctuation is big. And they can also, also electric vehicles can produce high torque at low RPM level. This requires mounting system which can react to high torque and mounts remain durable. So the basic need is, since the torque fluctuation is big, so we need to have mounts which are durable and big. So if we have a pendulum system with them, then the same mounts will have all the loads in X direction, because pendulum system specifically distributes the task and all the fluctuating torque is taken care in by X direction. But if we have a 3 or 4-point system, then the fluctuating torque is taken care by, is distributed between X and Z direction. The 3 or 4-point system, all the mounts are located above COG, and since the mass of the motor and the transmission is not very high, so the preloads on 3 or 4 mounts in Z direction is not very high. So generally the main load which is coming is a fluctuating torque load, and that we can easily distribute in X and Z direction. So conclusion is that electric vehicles will overcome IC vehicles quickly. Also, my personal choice for type of mounting system will be 3 or 4 point mounting system located above COG. Hope you like my video. If yes, please like it and subscribe to my channel for new videos on powertrain and chassis mounting system development, from system level calculations to product level. For questions or training, you can write in comment section or contact me on my email ID. Thank you.